that function? What's f prime going to be?
6x squared plus 6x
Mm-hmm.
minus 36.
Correct. So then what was step 2 after you found the derivative? What were you going to do next?
That equals 0.
So you have 6x squared plus 6x minus 36 is equal to 0. What should I do next if I'm trying to solve that? What should I do next? Liam?
36 to the other side.
No,
Or you could
it's a
factor
quadrant.
out 6.
You could factor out 6. You could absolutely move 36 over, but it's not really going to help you. So now what can you do? One word for what are you going to do now? One word. What are you going to do to this right here? We have the blue region and we have the green region, right? So you want to know, are they positive or negative? So let's do the yellow region, to the left of -3. Here's the derivative. Here's the derivative right here, to the left of -3. If I plug in -5, if I plug in -10, make it like negative 10. If I plug in -10, is it going to be positive or negative?
Positive.
It's going to be positive. What's between -3 and 2? That's a nice number to plug in.
1.
Sure, or 0, right? 1 or 0. So you get positive. Is it going to be positive or negative?
Negative.
It's going to be negative, and then it doesn't necessarily go back to positive, but in this case, does it?
Yes.
It is. So what does this mean? The function is increasing, decreasing, and increasing, so it's going to be a max and a min. So of these two values, you'd want to plug in f of -3 to find out what the output is. What do you plug that into? Where do you plug in -3?
The original.
Into the original, right? You plug in -3 into the original, so that's going to be 6 times 9 minus 18 minus what? 36, right? Oh, that's the derivative. We want to plug it into the original, right?
Yeah.
So we'll leave that there for a second. This is where I would let you use your calculator. Everything else, yeah, everything else. So if you plug it in, what do you get when you plug in -3, Eddie?
I got 159.
159?
Yeah.
That sounds right. Okay, the problem is we haven't used all the information at hand. What information have we not used yet? We haven't used the interval, right? Here's the thing. We can't go, it stops at -5 and it goes up to 5. We know that this function looks like this, right?
Yeah.
We know there's a max here, a min there. Well, here's the thing. This could be higher, right? We know that this one right here is what, -3, 159? Could this one be higher? So what do you have to test? You have to test two things. Just to be sure, test both endpoints. So this is what I'd like you to do, everybody, to practice this. Into y1, enter that. Enter that into y1 on your calculator right now. Take out your calculator, everybody, and put that into y1. Do that right. So the point here, critical points, the point is, everybody, if you have an interval and you're looking for maximum or minimums, what do you have to test? Not just the critical values, you have to test the what? Endpoints. Test endpoints. You have to test the endpoints. You have to test the endpoints. Sometimes they'll be given to you and sometimes you have to figure them out. Sometimes you have to figure them out. Okay, so we're going to move on to the big question of the day, which is this one right here. I want you to read this. Put your style. How much area could you enclose? So the 2,000 would be the circumference of the circle. If you want to find the area of a circle, what do you need? So the circumference is 2,000. What's the area of a circle, if that's r? The area is what? Pi r squared. So in this case, oh, well, the circumference is 2,000. What's the relationship between circumference and radius? What's the relationship between circumference and radius, Sarah? 2 pi r, yep. So if the circumference is 2,000, we have 2,000 is equal to 2 pi r, so it's going to be r is equal to 2,000 over 2 pi, which is the same thing as 1,000 over pi. So if we wanted the area of that circle, what would it be? Pi times 1,000 over pi quantity what? Squared. So that's going to be 1,000 squared pi over pi squared. That cancels. So what are you left with? 1,000 squared all over what? Pi. So if we made one fence, that's the maximum area. If we made one fenced-in area, that would be the maximum area. Can someone do that on their calculator for me? When I say someone, everybody should make a beeline for their calculator. Type that into your calculator right now. Tell me what it is to 3. It should be radius, right? Should be radius. It should be radius. So if we wanted to fill some things in right here, we could fill a few things in. What's the length of the yellow going to be? If the radius of that circle is x, if the radius of the yellow circle, the first circle, is x, what's the circumference if the radius is x? 2 pi x, exactly, very good. So this is 2 pi x, that's this distance. What's the blue distance going to be? 2 pi y. That's pretty cool. Hey, but what do we know the total amount of fencing is? How much fencing do we have total?
2 pi x plus 2 pi y.
So no, yeah, we have that much, but what does it tell us? What's the leadoff number? You're correct.
2000.
So what equation can we write, Caleb?
2000 is equal to 2 pi x plus 2 pi y.
So we have a nice relationship. Could we simplify that a little bit?
Yeah.
And divide by 2. We end up with 1000 is equal to pi x plus pi y. Let's just stop there. We don't know what we want to do yet with that, but that do we assume we're going to use that? Absolutely. So that's what we know right now. This is all we know. This is everything we know written down. What do we want? Are we trying to minimize the area or maximize the area? We're trying to maximize the area. We're trying to maximize. What's the maximum possible area? We are trying to, it's right here, maximize the possible area. Are you with me so far?
But he said at least 600 and...
Yeah, but those are the minimum for each. But overall, we're maximizing the combined area of those two circles. So if we're trying to maximize area, we need to write the equation for what? Speed? Want, max, area. So we need to write an equation for what? Yes, area. What's the area of circle 1? What's the area of circle 1? Pi x squared. What's the area of circle 2? Pi y squared. So if we want to combine the two areas, all we do with those two things is what? No. If those are the two areas we want, and we want the combined area, what do you do with the two numbers? Add them together. So the area we're looking for is this right here. But this right here, what's the challenge when working with this? How many variables do you see? Oh, we see 2 variables, right? But let's pause for 1 second, everybody. I want to pause. We can do a bunch of things. There's a lot of different directions to go in, but I want to pause right here. In the first equation, the first question of the day, we did all this calculus right here, but then we also had to test the what? We had to test the what? Endpoints, right? Let's find those endpoints first before we go any further. So what I mean by that is, you have 2,000 feet of fencing, right? Can all of them go into one of the circles? No. There's a minimum amount that has to go into each, correct? What do we know that the area of circle 1 has to be greater than or equal to? In the question, it says what? 1200 pi, right? What does the area of circle 2 have to be greater than or equal to? 600 pi, right? What's the formula for the area of circle 1? What's the formula for the area of circle 1? Pi x squared, do you remember that? We just put it over to the side. And we also know that pi y squared has to be what? Greater than or equal to 600 pi. What can we divide both sides by on each of these? Pi. You see that, everybody? So we have x squared is greater than or equal to 1200. I'm going to finish it on this side because we only need this side. So we take the what of both sides now. So x has to be greater than or equal to what? The square root of 1200. Are you with me so far? X has to be greater than or equal to the square root of 1200. Let's go over here for a second. How many variables do we have right there? 2. We really would only like to have one of them. When we like x, we kind of gravitate toward x because that's what we write equations in. So if we want it to be in terms of x, what do we need to substitute in? We want to get rid of the what? We want to get rid of the y. Hey, how can we get rid of the y? There it is, right? So what can you do with this? You could isolate the what? You could isolate the y value. So what do you get here? You end up with, you get pi y is equal to 1000 minus what? Pi x. So what does y equal? 1000 minus pi x all over what? Pi. So what can you do? Could you simplify that a little bit? Yeah, it's debatable whether this is considered to be simpler, but I'll take it. It's arguable, right? It's not definitive which is better or worse. You know, I personally like the one on the left because it's one fraction. So let's just take that one. Where can we plug this in, Caleb? For y. And why did we do that?
So that
We just have x. So what do we have here? Plus pi times what? 1000 minus what? Over what? Over what? Over pi. And what is that? That quantity is what? Squared. Does everybody see that that's squared? Because y is squared, so when we plug in for y, it has to be what? Squared. So why is this really useful now? How many variables do you see right there? I see right here No, well, it's A. A equals, A is in terms of how many variables right there? One variable. It's just x. It's just x. And what do we know? X has to be greater than what? Square root of 1200, right? So that's the lower bound, but there's also an upper bound. So that's the minimum amount you can use, right? So could it be bigger than that? Absolutely. The square root of 1200 is like 34 or something like that. But we need a max, right? We need a max. So how do we figure out the max? Our restriction, you have to be very careful about it, is this, again, this represents, I'll tag it here, that's circumference, right? Written poorly, right? So the max, so x has to be greater than or equal to 1200, but it also has to be less than or equal to 1000 pi minus what? Root 600, exactly. Exactly. Can you give me the decimals now, Sarah? What's the square root of 1200? What is that? What's the square root of 1200? Yeah. 641. And what is 1000 over pi minus the square root of 600? So that's the minimum value of x, and that's the maximum value of x. What are we doing over here now? We're going to find out, is there somewhere in the middle where it could go higher?
Wait, I think that's wrong.
Right?
You have to put pi in brackets.
You do, but I think it's 293. And what? 293.815. What are we searching for over here now? Something in the middle. Maybe it gets higher somewhere else. Do you understand what's going on? It could get higher somewhere. We're not guaranteed. Like over here, when we did this one right here, did this one almost get higher? It got to 151, but this one was 159. But we still have to check the endpoints. This one, by far, is the hardest one we do so far today because the endpoints are hard to find. We just found them, so the rest is pretty easy. So let's go back here. We have this equation. What do we need to do to this equation now? We need to take the derivative. Now, we might want to clean it up first, though. We might want to clean it up first. This is where actually that simplification is helpful because I'm going to rewrite it, everybody, just to make it a little easier for you to see. Plus, what is it? Pi times 1000 over pi minus what? To the 2. Taking the derivative of that is actually a little easier. Here's why. Try doing it now, Caleb. Tell me what the derivative is. What is a prime? 2 pi what? Plus, what do you drop to the front first on this one? You drop the 2, so it's 2 pi times 1000 over pi minus x to the what power? 1 to the first. But then what do you multiply by? Nope. Negative 1. Because what? It's a lot easier to see now, right? Like, what is the derivative of this? Negative 1. It's a lot easier to do the chain rule now. If you miss that negative 1, what happens? It doesn't work anymore. Like, the number you get will be completely off. What do we now set this equal to? We take this whole thing, and what do we set it equal to, Caleb? Correct. We set it equal to 0. So that's equal to 0. So what is that? That 0 is equal to 2 pi x minus 2 pi times 1000 over x not x. What is that? 1000 over pi. What can I factor out of all of this? I like factoring and not dividing. What can I factor out? 2 what? 2 pi. So what do you get? X minus 1000 over pi minus x. So what does that simplify to? 2 pi times what? X minus 1000 over x plus what? Because the negative gets distributed in. Plus what? Plus x. You see, I made that mistake too. Yes, I keep doing that. I don't know why I keep doing that. 1000 over. So you get 2 pi times 2x minus what? So if that's true, what has to be true? 2x minus 1000 over pi has to equal what? 0. This, what's the only way to make it 0? This has to be what?
500.
That has to be pi, because can 2 pi ever be 0? No. 0 product rule, so 2x equals what? 1000 over pi. So what does x equal? 500 over pi. Do that. What's the decimal for that? Someone do 500 over pi? Do 500 over pi. What is it? What is it?
159.155.
So do we have a new number to test in here? Yeah, and hey, it's right between the two. Point what? 155? Here's the thing we can test first, though. Usually when we find where the derivative is 0, we like to find out if it's a what or a what. A minimum or a maximum, right? We look at the derivative. Let's look at the derivative, everybody. Where's the derivative? The derivative is right here. The derivative is right there. Well, actually, let's look at the simplified one. Where's the simplified one? Right. Where's the most simplified derivative here? This is kind of the most simplified derivative right here, right? So let's talk about this. What number is to the right of 159? Like 200? Sure, you could do 160. I like going a little bit further. Do 200. Do 200. It's a lot easier to do, right? So what you do is, you know that that's always going to be positive, right? So then you use your calculator. Do this for me. Tell me what this is. So it's 2 times 2 is 400. 1,000 over pi is, do that for me. Do 400 minus 1,000 over pi. What is it?
81.
Yeah, so is it positive or negative? It's positive. Now plug in something to the left, like 100. Plug in 100. It's going to be what? It's going to be negative. Here's the thing. What does that mean that is? It goes down and then up. So what's it going to be? It's going to be a minimum. So you know that this is going to be a minimum. So where's your maximum going to occur? Or one or the other, right? So what you really want to do is this. You want to find the area at 34.641. Just for informational purposes, it'd be nice to know this. And what's the area at 293.815? Where's the area function, everybody? The area function is, where's the area function? Right there. You see the green, everybody? Type this in as y1 into your calculator right now, everybody. Do that now. Type that in as y1 into your calculator. Be really careful, everybody. Is it really easy to type that in wrong? Yes. Type that into y1 into your calculator right now.